topic is stimuli responsive generating nanoparticle for enhancement the EPR effect and intratumoral accumulation of the doxorubicins. We know the passive targeting of nanocarrier occurs due to the unique characteristic of the solid tumor. That is, in the characteristic of the solid tumor, it is the leaky vasculature and the defective lymphatic damage, which allow the nanocarrier in preferentially accumulate in the tumor tissue. And this is discovered by the 1986. When this is picture shows that the release of the when injured by the tissue, the release histamine can cause the small blood vessel to become dilated and leaky, resulting in the increases the vascular permeability and allowing more fluid and macromolecules immune cells as well as the nanoparticle to reach the injured tissue, passing out the small blood vessels. But it is proved that the conventional nanoparticle less than when the treatment in the blood vessel only 10% of the original dose reach in the tumor site. So this is the little problem of the EPR effect. So from this problem, in our work we design a new materials which is the peak dextrin molecule. This dextrin molecules which generate with dextrin H is compared to the NO2 group, and this NO2 group is released in the intracellular level in presence of glutathione. And we know the glutathione level in the tumor cell is much higher, so in presence of glutathione it releases the NO, and this NO is used as a vasodilator. And this is our scheme of this molecule. It shows that when we treatment of the nanoparticle, it go to the extracellular level, and boosted the EPR effect, and also chemotherapeutic drug of the doxorubicins we can incorporate in the nanoparticle, and the nanoparticle is go to the intracellular level, then NO and doxorubicin is released, and the apoptosis of the tumor cell will be occurs. So this is the enema data. It shows that the in presence of OH, they have the dextrin OH is the H coming in the aliphatic region of the enema spectrum. But in the case of the when NO2 is converted to the OH group, the dextrin H molecule is vanished. That is proof that NO2 group is attached with the hydrogen replaced by the hydrogen, and it is from the NO2 in the, and NO2 is converted by the hydrogen group, and NO2 is conjugated with the dextrin molecule, and NO-dextrin is the hydrophobic and PEG is the hydrophilic, and it is from a nanoparticles. So this molecule we prepare this characteristic, the intensity of this molecule measured by the DLS spectroscopy. It is proved that before the treatment of the glutathione, this molecule is stable, but after treatment of the 10 millimolar glutathiones, this molecule start to degradation, and when the photoluminescence spectra will measure, that its intensity is decreased with time when 10 millimolar glutathiones will be added. Then that means we prove that when the time dependent photoluminescence spectra, it degrade this molecule at a time. And this is the release profile of this release profile is proof that the nanoparticles it's much the release much higher in the 10 millimolar glutathione than the control, and the DOX control nanoparticle, it is also proved that in the presence of glutathione and absence of glutathione, they have near about same. That means they have it is in the case of the it is the proof that they have no release in this control molecule, but in the case of the DOX release molecule, that prove that in the presence of 10 millimolar glutathione, the NO its release is much higher, and then the doxorubicin release is much higher due to the higher EPR effect due to the NO group. And the this confocal microscopy image is proved that the DOX nanoparticle is from the NO in the intracellular level, and much release of the DOX compared to the DOX control nanoparticle and free DOX molecules. Now we explain the vasodilator effect of this vasodilator effect. That is the when we measure the laser speckle contrast imaging microscopy with saline nanoparticle treatment, it is proved that when nanoparticle treatment, the microvascular is became clear in the mice 6 hours and after the post injection, that implying the enhancement of the blood flow of the tumor vasculature. Atom vascular, and this is the enhancement of the EPR effect. And the two photon microscopy data is proved that two photon microscopy and the efficacy treatment with the blood vessel and the Texas rate in the in the tumor blood vessels, it is proved that nanoparticle treatment induced much more extravasation in the case of TR-dextrin molecule, TR-dextrin into the tumor tissue, and this more blood vessels implying tissue more implying the higher permeability of the nanoparticle compared to the control nanocan and saline treatment. So it is so this is due to the enhancement of this is proof that increase in the EPR, it is increase the EPR effect of the tumor cell when due to the generation of the and the dilated the blood vessels. This is we explain the in vivo biodistribution data and anti-tumor efficacy. It is proved that the results suggest that the nanoparticle had 1.75 higher accumulation in the tumor tissue than that of the control group. And this blood vessels and nanoparticle, and this is the called the and in vivo biodistribution. It is proved that a tumor when the dogs percentage measure, it is proved that tumor in the tumor cases, the free dogs and dogs control nanoparticle and dogs nanoparticle, the higher accumulation of the dogs nanoparticle compared to the dogs control and free dogs molecule, and this is due to the generation and the more and it is the dilated the blood vessel and vasodilation effect. Due to the vasodilation effect, most dogs concentration in the tumor cell compared to the free dogs and dogs control nanoparticle. And that anti-tumor efficacy is to the tumor volume its decrease is so much in case of the dogs nanoparticle compared to the dogs control nanoparticle, and the tumor weight also same decrease in the dogs nanoparticle due to the more accumulation of the dogs nanoparticle and dogs chemotherapeutic drug and the release in the intracellular level, and this intracellular levels the dogs release and more apoptosis of the tumor cell compared to the dogs control nanoparticle and free dogs. So it is so all the data above data shows that the control molecules this it's dilated the blood vessel and used as a vasodilator, and the enhancement of the EPR effect of the molecules. Thank you.